Hey guys, to discuss how computer store images or how computers handle the images and the binary code, let's take a look at this lovely house that my daughter drew recently. So when you zoom on any image, when you zoom in into the image, we notice that the image is consisted of many small squares. Each square of these is actually what we call it a pixel. So in each one of those squares, you have one color only. So if you look at this picture, the computer have many squares. Each one of those squares have a color. So to make it easier, I'm going to take a very small part of this picture. So let's assume this part only. Let's see how the computer store the data of that small part of the picture. So each pixel have three values to be stored. Good. For each pixel, we need three different values. The first value is the location of the pixel. Where is he on the x axis of the picture? So is he in the first row? Is he in the second row? Is he in the third row? So for our first pixel in the picture, the red one here, it is a 1. So where is he on the y-axis? Y-axis here is also on the 1. Good. Now the third value he needs is what color? Now I'm assuming this picture is a very low quality. I don't want to go in details about what happened to the higher quality pictures. So now the file have three values, and of course he have to store it in the bytes, in the zeros and the one. So the XL have his value, whatever that number, 8-digit bits to point number one. Then we have for number one for the YXL, and then for the color coding, he have a specific binary code for the color coding. So for this small tiny pixel, we will require three different bytes. Each byte represent X, Y, and the color. Good. Now we go to the next one, the one next to it. Good. So now it's the X axis, the row is the row one. The column is in the column two because the first row, second column, good, and the color is black. Again, we will get three different values. Good. The binary value that equivalent to the number one, the binary value that equivalent to number two, the binary value equivalent to the black color. Again, each color has its own binary code, depend on the quality of the photo. I'm not going to discuss this. I'm just assuming numbers for now. So I'm assuming that the red is this number, whatever the actual value is. Then if we decided to talk on another pixel, let's talk this first white one here. So this will be in row number 2, column number 9. So row number 2, column number 9. Again, it will has the value for the X and the Y axis and the color. Good. At the end, for every pixel, the system will have those three values: X, Y, color, X, Y, color. So if you somehow manage to open the file of the file of the photo in a way you can read the zeros and the ones, you will find that something similar to this. Of course, you won't be similar to this, but logically thinking. So now, if I'm a computer, I want to show this photo to my user who asked me to open it, I will read this number. So that will tell me which pixel it is, which row, this number, which column, this number, which color. So now from these three sets, I know the first pixel is in the first row, first column, it's color red. So I will show him red here. Then tick for the next pixel. Number 3 for the third pixel. And like this, until I get what? The entire pixel. Just to let you know, a tiny picture like this, something like this tiny house that we just painted now, it could have thousands of pixels. So for example, this one, good. If I just want to show you this one, how many pixels it has. So this picture, which is a very low quality picture, it has 213 pixel by 272 pixel across the picture side. Good. Again, so this is how the files, the computer store these pictures, and all these zeros and one will actually combine together to generate the file. Of course, I'm talking here about the way that BMP files are stored. I'm not talking about the GIF or the GI, the GPG or any of the other photo, but that will give you a roughly idea.